balance the equations below, assuming they occur in a basic solution. No, not a basic solution. You'll see why in about 2 seconds. So we have our balanced equation. We have SO32 minus, that's aqueous, plus CuOH2 solid, which will yield a sulfate, so SO42 minus, plus CuOH. Now, we need to balance this in a basic solution. So whenever they tell you that we're balancing in either an acidic solution or a basic solution, we have rules. This is not normal balancing where we just use coefficients. There's rules to the madness. So for these problems to work, it's just best to memorize all the steps that I have laid out here for you. Now, since we are trying to balance in a basic solution, we're going to skip down here, right? But the first step for any basic solution is you always got to get the acidic answer first. Why? That's why. That's why we don't like basic solutions, because we have to do the acidic answer, and then we do a little bit more work just to get that basic solution. So now we're reverting back to, well, what would be the acidic solution answer? So here we go. Step 1 for the acidic answer. We have to break this whole reaction into 2 half reactions. Now, this is just as simple as just looking and seeing what substances go with what. So you're going to pick one on the left to match it up with one on the right. Pick the elements that go together. So it seems like I have a sulfur and an oxygen, right? And I'm going to mix it with the sulfur and the oxygen, right? SO4. So here's one half reaction. And then my other half reaction, it kind of makes sense, right? I have CuOH2. So I have copper, oxygen, hydrogen. And then I got copper, oxygen, hydrogen. So here are my matches. So this is going to go with this. Beautiful. And this one is going to go with this one. It does not matter which one you write first. So I guess I'll write the sulfites and the sulfate ones. So we have SO3, 2 minus. Now, in terms of states, right, this sulfite is aqueous. For balancing purposes, I do not care. So when you're doing your work, just make it as easy as possible. Don't even worry about these. But once we get the answer at the end, we'll just make sure that we put these in with their appropriate, substance. So I have SO32 minus, which goes with SO42 minus. And then I have the CuOH2 goes with the Cu. I don't know why they put this in parentheses, but sure, CuOH. First step, done. Second step, now we have to balance all elements except for hydrogen and oxygen. So I don't care about hydrogen and I don't care about oxygen at this point. I'm only looking at all the other elements. And notice, as we're going to run through these, we do step 2 for both of these. Then we go to step 3 for both. We go to step 4 for both, etc., etc. You don't want to run through step 1 through 8 for your first reaction and then come back and do 1 through 8 for the other one. So we're always going to work together. So balance all the elements except for hydrogen and oxygen. You got it. I got 1 sulfur here. I have 1 sulfur here. So that's already balanced. Some of these steps we will be able to skip over. Let's go down to the bottom one. I have 1 copper and I have 1 copper. So that one, we just, bye-bye, skipped right over step 2. Beautiful. Now we're on step 3. Step 3 says we are going to balance oxygen by adding H2O. So notice that it's always oxygen and then comes hydrogen. And the rules here is that if you need 1 oxygen on one side, you're always going to add it as 1 H2O. So if you need 2 oxygens on one side, you'll add 2 H2Os. And if you need 3 oxygens, you'll add 3 H2Os. So let's see. I have 3 oxygens on the left side. I have 4 oxygens on the right side. So it seems like I need 1 more on this side. So I'm going to add just the 1 H2O because I only need that 1 oxygen. Now let's come down to the bottom here. I have 2 oxygens and then I only have 1. So seems like I need to add 1 on my product side. So I'll say plus, and then 1 H2O. Beautiful. Step 3 is already done. We're almost halfway through the acidic answer. Now, we're going to balance those hydrogens by adding H+, and please do not forget that positive sign. This is hydronium. That's what makes it acidic. So, likewise, if you need to add 1 hydrogen to one side, you're going to add it in terms of 1 H+. So, 2 hydrogens, you're going to add 2 H+. So, let's see. On this side, it seems like I have 2 hydrogens. On the right side, I don't have any. So I need to add plus 2 H+. And now let's do the bottom. I have 2 hydrogens on the left side. I have 1 hydrogen, so 1, coming in plus. I have 2 hydrogens here, so 1 plus 2 is a total of 3. I have 3 total hydrogens on the right side. I have 2 total hydrogens on the left. Seems like I need 1 on the left side. So I will say plus H+. And I guess I really should have swapped these colors, right? H+ acidic usually is red, but please forgive me. Let's just keep going, right? Halfway there. Now comes the fun part. Now comes the electrons. All the elements are balanced, so now we have to balance the charges. And we do that by adding electrons, which are always going to be represented as E-. Remember, electrons are negative. And you're always going to add those electrons to the more positive side. So when this step happens, what I like to do is I like to just put a little divider here, just to say to myself, I am never going to cross over the divider. Whatever charges are on the left stays on the left. The charges on the right stays on the right. And what I'm going to do is I'm just going to bring this down a little bit just so that I have a little bit more room. Because we need to tally up what the total charges are on the left and the right side. But it's pretty simple because all you're looking for are numbers in the upper right-hand corner. So for example, sulfites, I already see a -2, so I'm going to take that into consideration. But for water, I don't see a number in the upper right-hand corner. Anytime that you don't see a number, that's always a 0 charge. So I have 0 coming in for H2O, literally plus, so I'm going to add. The total charge for the sulfite was a 2 negative, and there's only one of them. So 1 times a -2 is a -2. So if I add the total charge on this side, it would be a -2. Okay, let's do the same thing for the right side now. Sulfate, I have a -2. I only have one of them, so this would be a -2. Plus, so -2 plus. Now here comes a positive. That means +1, and there's 2 times +1. So I actually have a total of a +2. So whether you want to say +2 here, that's fine with me. So -2 plus 2, they cancel out. 0. And that's the total charge for the right side. You're always going to add electrons to the more positive side. So out of a -2 and a 0, you have to say which one is more positive. 0 is, higher in value than a -2. So you're going to add electrons to the right side here. And how many jumps you need to get from the 0 down to the -2. So if you think on a number line, 0 to -2, I need 2 values. Now we're just going to do the same thing for the bottom one. So let's see. Here I have an H+, that's a +1. There's only one of them. So the overall charge here would be +1. Plus, right? CuOH2, I don't see any charge in the upper right-hand corner. That means 0. So it doesn't matter how many I had. 0 times whatever number is always a 0. And +1 plus 0 is a overall of a +1. Let's do the same for the other side, but here I don't see any value, so that's 0. H2O, just like before, no value, so that's 0. They're coming together, so plus, so 0. Same thing, always to the more positive side. Plus 1 is more positive than 0, so I know that I have to add my electrons on this side. How many? Well, it takes me only one jump to go from a 1 to a 0, so I just add 1 electron. And now, number 5 is done. However, number 5 is a pretty important step because there's more information that you could answer by just doing number 5. So, sometimes when you're doing acidic or basic solutions, you might have to determine which one is either the reducing agent, which is the same thing as the oxidant, or whether something is the reductant, aka the oxidizing agent. Where these electrons are located will tell you which one is which. Just know that an oxidant is always, or the reducing agent, is always the one that's undergoing oxidation. And if you think of Leo the lion says grr, a loss of electrons is always oxidation. So LEO, loss of electrons, oxidation. And that always means that the electrons are going to be on the product side. Vice versa, the reductant, or the oxidizing agent, is always the gain of electrons. That's reduction. And the electrons are going to be on the left side. So I see that I have my 2 electrons on my right side here, and my 1 electron on my left side here. Now just keep in mind, out of these 4, only your starting material can either be the oxidant or the reductant. Your products will never be a reducing agent or an oxidizing agent or an oxidant or a reductant. So if this was like a multiple choice question and they give you these 4 choices, A, B, C, or D, you already have a 50-50 shot because these will never be a reducing agent or an oxidizing agent. So your oxidant is always the one that's the electrons are on the product side. And that's this equation. And who got you there was the sulfite. So the oxidant is SO3, 2 minus. And if you want to say aqueous, that's fine as well. And then the reductant, if you know one of them, you got to know the other. So the reductant is going to be the CuOH2, and that's the solid. So we just answered those questions. That's beautiful. So that's like a little side note. And now let's continue. So after you add those electrons, and it's a good check, your electrons have to be on opposite sides. If you have 2 equations in which you have electrons on both sides, go back. Something happened. Silly mistake somewhere. But now we're on step 6. We just have to balance those electrons. And we balance them by multiplication. So I look at my electrons and I say, I got 1 electron here. I got 2 electrons here. How am I going to make these the same? By multiplication. Well, I could take the bottom one, the bottom whole equation, and times it by 2. Because 2 times 1 is 2, and then your electrons are going to be balanced. However, you got to be fair. If I times this by 2, I have to times everybody in the equation. How fun is that, right? So let's just go from left to right. 2 times 1 electron is 2 electrons. Plus, we have now 2H+. Plus, I now have 2 CuOH2. And that all yields 2 CuOHs and 2 H2Os. So 2's all around. Once you write your new equation, the first one is donezo. Goodbye, never to be seen again. And now what I want to do is I might have to manipulate this a little bit because I kind of want to make this better for you. So let's just bring this equation because we didn't touch this yet. Right? This one should be good to go. And I will manipulate them in a little bit. So just pause the video if you need to, because all these charges, we don't need them anymore, so we could get rid of them. So pause the video if you need to write anything down, but I'm just going to, fix some things up here. So I'm going to erase the charges. That's, oh, goodbye. I'm going to erase the old one. Maybe I can just do this, right? That would be much easier. Get rid of all this. We don't need that. Get rid of the charges. That's fun. And now I think we have both of these equations. So I'm just going to bring this back up. This looked like it was like right there. And then this is going up here. Beautiful. All right. So now, since we have 2 electrons on both sides, I'm going to say that number 6 is done. We're almost at the end of acidic solutions. We want to cancel like substances on opposite sides out. Basically, what we're trying to do is we're trying to simplify. That's why you want to get those electrons to be themselves, or, the same number. Because in a regular balanced equation, you never see those electrons. So goodbye and goodbye. Let's see. Does anything else cancel? Well, actually, yeah, right? I see that I have 2 H pluses on my left side, or actually this is my right. I still have no idea what my left is from my right. And I have a college degree. Anyway, we have 2 H pluses on this side, right? They cancel. So goodbye. Goodbye. Anything else? Well, here's an interesting one, right? I see that I have H2O on my left side, and I see that I have 2 H2Os on my right side. I can't cancel them out completely because I don't have 2 on both sides, but I can simplify by saying, if I get rid of 1 H2O, how many H2Os would be left here? Yeah, only just 1 H2O, because 2 minus 1 is 1 left over. Now, there's nothing else that I can cancel out. So everything that's on the left now stays on the left. Everything on the right stays on the right, because we are at the final step for the acidic. You're just rewriting it as one equation. Doesn't matter who goes first. So I'll just say that this is SO3 2 minus plus 2 CuOH2 yields, we'll say SO4 2 minus plus 2 CuOH, and then just plus a lonely H2O. That's our acidic answer. So if they said we wanted it in an acidic solution, this would be the final answer. But now, we just completed step 1 on the basic solution. Fun. So let's just keep going. Now we're just going to add to that acidic answer. So step 2 says that we need to add as many OH minuses as you have H plus, and you have to do this on both sides because you got to be fair. So I'm scanning this, and I'm saying to myself, well, wait a minute. I have to have H plus, right? That was the point of an acidic solution. But if you notice, when we did our cancellations, we got rid of all of the H pluses because there was 2 on both sides. Hence why there's no H plus in my equation. So can I add any OHs? No, I don't have any H pluses, right? I don't have any acidic component to basically cancel out with my basic component, which is the hydroxide. So there's really nothing that I can do. So basically we're going to skip over step 2. And if we didn't touch anything, and the last step is to simplify, I can't do anything, right? So step 3 is done. This answer is the basic answer. It's also the acidic answer, but since they asked for basic, that's what it is. This is basic. So this is your basic solution. Now, since we have everything good to go, I'm now just going to go back and I'm going to add in those states. So the SO3 was aqueous. The CuOH2 was a solid. The SO4 was aqueous. This guy was solid. And just know that the water that you add is liquid, because we're, dealing with acids and bases. And that's it. So this is your answer. Oh, yeah. Whew. What'd you think? I really hope this helped. Thank you so much for viewing the video. Subscribe to the channel if you would like to help us out. And I hope you guys are doing great out there. Let's keep studying hard. Good luck on your future tests and quizzes. And I will talk to you all in later lessons. And I think that's it for me. I'll see you in the next lesson. Bye-bye.